Over the last 8 years, generative AI has completely changed and transformed not just itself, but also the world around. And all of this started with the invention of the transformer architecture, which is based on a so-called attention mechanism. Without going into too much details, we can see that it is now all around us. We can see that almost everyone would be at least knowing ChatGPT or Gemini, if not actively using them. And mostly these use cases are not just for fun, but they are actually supportive and helpful tools in so many different professions and even in private life. However, the development is so rapid and so fast that industry is not able to catch up at the same speed. And so there are many different areas in which there is still a lot of potential to integrate these generative models. And one such area is animal welfare and veterinary science. Particularly in rural areas of the developing world, there is very little access to up-to-date knowledge or qualified professionals. While this affects all animals, it is particularly evident for the street dog population. As there is no control of population growth, huge dog packs roam the streets in search of something to eat. Living in unsanitary conditions, infectious diseases spread amongst them. They find very little support in the human population, which does not understand their needs or how to deal with them. Every day, countless puppies are born into this unwelcoming world of pain, disease, famine, and many times death. As you can see, there is still a lot of suffering in the animal world. And while such a veterinary assistant is not going to fundamentally solve the problems of, for example, street dog populations, it might be a supportive factor in helping decision makers make better and more informed decisions, or even in just raising the public understanding and awareness of how animals should be treated and how they work, how they behave. So in that sense, it might help, and that is all I can hope for. Now, to start implementing such a veterinary assistant, we first need to have access to quality data. And I chose to use articles from the Merck Veterinary Manual, which is a well-respected source of veterinary science articles. And to retrieve these articles, I couldn't rely on an API because there was no API. And so the only available option was web scraping. To scrape content from the web, there are basically two options that we have. The first option is to use something like the requests package in Python, which allows us to make HTTP GET requests and therefore retrieve HTML content from websites. After that, we can use a so-called HTML parser, such as Beautiful Soup, to parse that HTML page for relevant information. This is a pretty cool and especially very fast method, but it has a few downsides. Particularly, we are not able to retrieve content that has to be dynamically loaded. For example, if you need to click on a button and this button click triggers some JavaScript function that then retrieves some content from somewhere else. Now, a tool that can help with that is a so-called web automation tool, which is a tool that allows you to interact with the browser through code, so automatically. And this is quite cool in itself, but it also solves the problem that we had of the dynamic content. Because now what we can do is we can just click on that button, wait for the content to be loaded, and after that scrape whatever was loaded. Now, an additional advantage of these tools is that they are quite commonly used when designing agents based on large language models that need to interact with the web. A big downside of this approach is that it is much slower, because we are no longer able to get away with a simple HTTP GET request, but instead we need to load a full page instance. However, if you don't have that much content to scrape, that doesn't make such a big difference. And in my particular case, there was not that much articles on this Merck Veterinary Manual website. So I opted for Playwright, which is a popular web automation tool that is commonly used to design agents as well. Okay, so now having a look at the code base, we can see that there are two main functions. There's the crawler.py function and there's the scraper.py. Crawler.py is responsible for giving us a set of content URLs, which means URLs on which we can find actual articles about veterinary subjects. Scraper.py then will go and take this list of content URLs and create a markdown representation that it then adds into a JSON file. Let's have a look first at the crawler.py function. Here we can see the website that we want to scrape, which is the Merck Veterinary Manual. So to get some intuition, let's first have a look at that website. We can see that there's a lot of different things on that website, but the two sections that we want to focus on is the one for veterinary professionals, which has again a few different subsections on all the different interesting topics, and the second section is for pet owners. So here we can see in the subsection for dogs, for cats, for horses, and so on. What's also important to note is that once we click on that dog section, we can find additional sections, and in these sections we can again find additional sections and so on, until at some point we might find actual content, for example here. So this is an actual article. So that means that our scraper function, or actually our crawler function, should be able to take that into account and find all these different nested articles. So let's have a look at how we can do that. The starting point is the main function. And in this main function, we first initialize the Playwright object, as well as the browser object and the page object, which then allows us to automatically, meaning through code, navigate on the Merck Veterinary Manual website. The main function we call after that is the crawl function. And here, without going into too much details, the main functionality happens in this while to explore loop. So while there are still URLs that we need to explore, we just take the first one. Now, of course, if we have already seen it, if we have visited it already, we just continue. And otherwise, we go to that URL with the page object that Playwright provides to us. Now, there could be a few problems when trying to do that. One could be that the URL is not really a proper URL and it doesn't work for whatever reason. So in that case, we fail to load that URL and we can just continue. Because it is not working properly, we just continue with the next one. It could also be that we get a response status 403, which means that our requests to access the website are being blocked. And this happens if there has been too much activity from our particular IP address. So in that case, we know that we could still explore this in the future once the block is released. But for the moment, we should just terminate, and that's why we raise an exception. But now suppose that we managed successfully to access the website. The next thing we need to do then is to find out if the website we are looking at is an article or if it's just an overview website. And this we can do with that particular line of code. So if we find a data test ID with the name of topic main container attribute, it means that we are looking at an article. And so in that case, we just add that article to the content URLs that we've already found. Otherwise, we need to go and scrape or look on that particular website for additional URLs that link to further content. So we do so with this find URLs page function. So we do so with the find URLs function. Basically, the most important point here is that we want to skip or not take into account a certain number of links that are either empty or they are external links, which means they link to a page other than the work veterinary manual, or they are irrelevant, meaning they lead to sections of the Merck veterinary manual that we don't deem important because they don't contain articles. So these sections you can see here, these are not things where we find articles to scrape. Now, after we found such URLs that potentially are interesting, we just update our to explore list with those URLs. We also update the visited list by adding the current URL so that we don't have to visit it again. And then we just continue with the next URL. So in this way, we traverse the website starting from our two seed URLs in a fashion that is quite similar to depth first search or breadth first search, except that we are working on sets so that the order is lost. Now, having talked about this, let's see how the scraper actually goes and scrapes content once it has a certain content URL. As before, scraping starts in the main function. We start by initializing the browser, the playwright instant and the page object, as we already know. Then we retrieve the set of URLs to be scraped, either by looking in the content URLs if we are just starting out, or if we have already done some work, we will find them in the toscrape.txt file. In the main loop, we can see that we scrape the article. So let's have a look at what this function is doing. First, we start by going to the respective page and handling any errors that might come up in an appropriate way. Then we extract the title element, which can be found in the first H1 heading. After that, we need to extract the main content, which can be done with the element to markdown function once we have retrieved the appropriate container, which is, one more time, the topic main content container. We have already seen this in the crawler. So in the element to markdown function, we just go through all the children of that particular element, and depending on the type of that child, we decide what to do. If we find a heading, we just add that heading to the markdown file. The same goes for a paragraph. If we find a paragraph, we also just add that paragraph to the markdown file. Now, if we find a container or a section element, it means that we need to look within those containers or section elements. And that means that we just call element to markdown recursively so that the child is also represented as a markdown element. With that, we are able to get a complete representation of our article. So once we have this content retrieved, we just have to return the article as a dictionary containing the name, the link, and the content. Going back to the main function, we can see that once we are done with retrieving all these articles, we just need to update our Merck articles dataset. Again, we need to make sure that we don't lose our progress, so we extend the already retrieved articles and then appending whatever we have just found to that. So now, with that being said, we are more or less done with the preparation, and now we have a functioning dataset that we can use to improve our chatbot and make its responses more trustworthy and reliable. So let's have a look at how we can do that. The implementation of the so-called vetbot happens in a Kaggle notebook. And maybe the first important and interesting part of the code is the definition of a custom embedding function, which allows us to embed documents as well as user queries, as you can see here. The second important step is that we need to retrieve the articles that we've just created by loading them from the GitHub repository where they are in. After that, we create LangChain documents that can be uploaded to the vector store later on. The vector store we want to use is ChromaDB, which is quite sufficient for this purpose and easy to use. We start by creating a ChromaDB client, and then we create a database with our custom embedding function. Finally, we need to upload the documents in batches so that we can stay within the limits that are defined by ChromaDB. Now let's get a bit into the prompt engineering part. Here we can see that we define a class which consists of different types of queries. And the reason why we need these 3 different types of queries is that initially when we are just starting to interact with the chatbot, we want to give him very detailed instructions. And this happens in this initial instruction prompt. Maybe let's have a look at the summary for a bit so that you understand what the main points are that I was focusing on. First of all, I would like the chatbot to be able to ask follow-up questions if the user didn't provide enough query. If you remember how it is to go to a doctor, they would always ask you questions, and this is exactly what the chatbot should also do. Then the statements of the chatbot should always be based on the provided articles. I really want to avoid hallucination, and so that is a very important instruction, and it should also prioritize accuracy and caution, as in this health domain, mistakes are quite critical. The reminder instruction is just a short summary of all these important points. Now we go to define 2 different functions, which is on the one hand the retrieve relevant articles function, which just takes the user query and then uses it to retrieve the 10 most similar or most relevant articles from the ChromaDB database. Next, we define an augment query function, which is basically dependent on the query and the query type that we've just seen. So in an initial query, we just use the initial instruction prompt, the user question, and later on we add all the relevant documents. For a reminder query, we do the same with the reminder instructions, and for no instructions, we don't append any instructions in front of the query. Now, the chat interface consists of a lot of different parts, and I don't want to go into too much detail here, but the core logic happens in the onSubmit function, which is triggered whenever someone submits a query. Here, depending on the number of turns, which we can calculate based on the length of the chat history divided by 2, we augment the query appropriately and then feed it to the chatbot. After that, we just display the output. Now maybe let's have a look at how everything actually looks. So this is the final interface. I have prepared a small sample question that I can just read to you. So it says, I have a small puppy and I would like to train him so that he respects my boundaries and is generally well behaved, while also not being too strict in correcting him. Any advice? So let's see what happens if we take that and paste it into the chat. So it's thinking. Okay, so here we get a response. First, he is asking us a few questions. So how old is the puppies? Because they have different developmental stages. What breed is it? Because the breed can affect temperament. What specific behaviors are we hoping to prevent? So all of this is quite nice. So he's asking follow-up questions that we can then answer. And then there are some general tips. All of them are referenced with respective articles. And finally, in the end, we can also see the articles that are being used. So I hope you enjoyed this introduction to this veterinary assistant. And the next stage of the project will of course be to create an actual user interface, not just in a notebook, but as like a web application or a phone application, so that actually people can easily use it, which is the most important point. And then after that, there are of course more ideas for improvement, but this would be a good starting point. Thanks for your attention.